हेलो स्टूडेंट्स, दिस इज़ डॉक्टर रुचिरा चौधरी। इन्फिनिटी मैथ में आपका स्वागत है। इफ़ यू आर स्टडिंग बीएससी और बीटेक मैथ और यू आर प्रिपेयरिंग फॉर एनी कॉम्पिटिटिव एग्जाम वेयर हायर मैथमेटिक्स इज रिक्वायर्ड, then this channel will be helpful for you for gaining the knowledge of higher mathematics. So subscribe my channel and give me comments, and through your comments please let me know for the topics you want to discuss with me. So today I am going to teach you matrices for basic conception, which will be helpful for the beginners and also for the students preparing Z main and advanced. So let's start with the definition. So what is a matrix? A matrix is a rectangular array of mn elements into aij into m rows and n columns, where the elements aij belong to some field f. If the elements belong to the field of real numbers, then the matrix is said to be a real matrix. If the elements belong to the field of complex number, then the matrix is said to be a complex matrix. So there are m rows and n columns. This is rectangular in shape, so this is a matrix. So this suffix indicates where the element is situated. A11 means the element is situated in the first row and first column. A23 means the element is situated in the second row and third column. Since there are m rows and n columns, so the order of the matrix will be m by n. Matrices are written in these two different forms, either in the first bracket or in the third bracket, and matrices are generally denoted by the capital letters A, B, C, D, etc. And null matrix is generally denoted by capital O, and capital O 2 by 3 means null matrix of order 2 by 3. So there are 2 rows and 3 columns and all the elements are 0. 2 rows and 3 columns and all the elements are 0. This is a null matrix of order 2 by 3. Now there are 3 different types of square matrices: diagonal matrix, scalar matrix and identity matrix. These are all the examples of square matrices. What do you mean by a square matrix? When number of rows is equal to the number of columns, then the matrix is said to be a square matrix. Now what is diagonal matrix? A square matrix is said to be a diagonal matrix if all the elements other than the diagonal elements are 0, like 1, 0, 0, 0, 2, 0, 0, 0, 5. This is a diagonal matrix because this is a square matrix because the order of the matrix is 3 by 3, same number of rows and columns, and all the elements other than the diagonal elements are 0, and diagonal elements may be or may not be 0. Then this is a diagonal matrix. Now I am coming to scalar matrix. A diagonal matrix is said to be a scalar matrix if all the diagonal elements are same scalar. So there is a diagonal matrix. If all the diagonal elements will be same, then this diagonal matrix will be converted to a scalar matrix. For example, 5, 0, 0, 0, 5, 0, 0, 0, 5. All the diagonal elements are same scalar, so this is a scalar matrix. I am coming to an identity matrix. A scalar matrix is said to be an identity matrix if all the diagonal elements are strictly 1. So if the diagonal elements be 1, then the scalar matrix will be converted to an identity matrix, like this: 1, 0, 0, 0, 1, 0, 0, 0, 1. This is an identity matrix of order 3. This is generally denoted by I3. Now I am coming to algebraic operations on matrices. Algebraic operations means addition, multiplication. So at first I am coming to addition. A and B, two matrices A and B are conformable for matrix addition if they have same order. So in order to get A plus B, A and B should be of same order. Like if A be a matrix of order 2 by 3 and B be a matrix of order 3 by 4, then since A and B are of different order, then A plus B will not exist. So if you are asked to find A plus B, then the answer will be like that: A plus B does not exist because A and B are of different orders. So in order to get A plus B, A and B should be of same order. This is the first condition to get A plus B. Now how can you find the addition of two matrices? Suppose A be the matrix like this and B be the matrix like this. Since A and B are of same order, so A and B are conformable for matrix addition. So A plus B is defined. Now take the 1 1 position and take the 1 1 position of A and 1 1 position of B. So the element of the 1 1 position of A, A1, plus the element of the 1 1 position of B, B1. Similarly, A2 plus B2, A3 plus B3, A4 plus B4. So you are getting the elements in the resultant matrix by adding the corresponding elements of A with the corresponding elements of B. So the order of the matrix again is 2 by 2. This is the process of adding A and B. Now I am coming to matrix multiplication. Two matrices A and B are conformable for matrix multiplication if number of columns of A is equal to the number of rows in B. Suppose A be a matrix of order m by n and B be a matrix of order n by p, then since number of columns of A is equal to the number of rows in B, so the matrix multiplication AB is defined and the product matrix AB will be of order m by p. This n will be omitted and AB will be of order m by p. Suppose A be a matrix of order 2 by 3 and B be a matrix of order 4 by 2. Since number of columns of A is not equal to the number of rows in B, so the matrix multiplication AB, the product AB is not defined. But since the number of columns of B is equal to the number of rows in A, so the product BA is defined and BA will be of order 4 by 3. Now how can we find multiplication of two matrices? Suppose A is a matrix like this and B is a matrix like this. Since A is of order 2 by 2 and B is of order 2 by 2, so the product matrix AB will also be of order 2 by 2. There will be 2 rows and 2 columns. Now it's time to find the elements of the product AB. To find the elements, at first you have to take the first row of A, and this first row of A is fixed, and take the columns of B 1 by 1. So A1 at first, this first row and first column. So A1 B1 plus A2 B3. This is the first element. A1 B1 plus A2 B3. Next you have to take first row of A and second column of B. So A1 B2 plus A2 B4. A1 B2 plus A2 B4. Next you have to take to find the second row of A. To find the second row elements of the product matrix AB, you have to take the second row of A and the columns of B one by one. So at first second row of A and first column of B. So A3 B1 plus A4 B3. A3 B1 plus A4 B3. Next you have to take second row of A and second column of B. So A3 B2 plus A4 B4. A3 B2 plus A4 B4. These are the elements of the product matrix AB. Now I am coming to transpose of a matrix. Suppose A be a matrix, then A transpose is generally denoted by A T or A capital T and is obtained by interchanging the rows and columns of A. So if A be a matrix of order m by n, then A transpose will be a matrix of order n by m. So if A be a matrix like this, A1, A2, A3, B1, B2, B3 and C1, C2, C3, then A transpose will be obtained by interchanging the rows and columns of A. Like this column A1, B1, C1 will be changed into a row like A1, B1, C1, A2, B2, C2, A3, B3, C3, and this is also a matrix of order 3 by 3. Now from the transpose of a matrix we can get two important matrices, that is symmetric matrix and skew symmetric matrix. Symmetric matrix, a square matrix is said to be a symmetric matrix when A equals to A transpose. That is, in that case Aij will be equal to Aji. That is, this is the example of a symmetric matrix. If you notice carefully, you can see that the element in the 1, 2 position is same as the element in the 2, 1 position. The element in the 1, 3 position is same as the element in the 3, 1 position. The element in the 2, 3 position is same as the element in the 3, 2 position, that is Aij equals to Aji. If you make transpose of this matrix, you will get the matrix A itself as a return. Next I am coming to skew symmetric matrix. A square matrix is said to be a skew symmetric matrix if A equals to minus of A transpose. That is, in that case Aij will be equal to minus Aji. So this is the example of a skew symmetric matrix, and if you notice that, then you see the element in the 1, 2 position and the element in the 2, 1 position are equal in magnitude but opposite in sign. That is Aij equals to minus Aji. Similarly, element in the 1 3 position and the element in the 3 1 position are equal in magnitude but opposite in sign. But in case of skew symmetric matrix, the diagonal elements will be strictly 0 because the diagonal elements are denoted by AII. Since this is 1 1 position, 2 2 position and 3 3 position. But since Aij equals to minus Aj, therefore Aii will be equal to minus Aii by this condition. So 2 Aii will be equal to 0 implies Aii equals to 0. That is, the diagonal elements will be strictly 0 in case of skew symmetric matrix. So this is all about the introduction of matrices and some definitions. If you want anything more related to matrices, let me know through your comments. My other video links will be given in the description box. And my next class will be about some problem solving of matrices. So stay connected and follow my next video link.